Hello all. So in the last sessions we were talking about classification algorithms. We've already covered two classification algorithms which are KNN and decision trees. So today in the session I would like to cover about one more important classification algorithm which is Naïve Bayes algorithm. Okay, so classification algorithms are classified into so many different types, out of which Naïve Bayes algorithm is one of the most important one. Okay, so Naïve Bayes classifiers basically belongs to family of algorithms based on Bayes theorem. Okay, so despite the naive assumption of feature independence, these classifiers are widely utilized for their simplicity and efficiency in machine learning basically. Okay, so as you can see, the naive Bayes classifier is a probabilistic machine learning algorithm which is based on Bayes theorem. It can be used both for classification and regression, but most probably we use it for classification algorithm. When you talk about text classification, okay, so when you talk about email filtering, spam detection, or when you talk about sentiment analysis or review on a product, okay, so when you have this sentiment classification, okay, so we have to give a movie review and then say whether it is positive, negative. Okay, so for text classification kind of application where probability of the words is taken into consideration, we use such kind of algorithm which is called as Naïve Bayes classifier. Okay, so as I told you, there are two words in this, naive and Bayes. Okay, so the term naive comes from the assumption that all the features are independent. Okay, in reality this assumption is often not true, but the classifier still works well in so many other applications. Okay, the second term Bayes is used because the Naive Bayes classifier is totally dependent on Bayes theorem. Okay, so when I talk about Naive Bayes classifier, Naive Bayes classifier basically are the collection of classification algorithms which are basically used dependent on Bayes theorem. Okay, it is not a single algorithm but a family of algorithms where all of them share a common principle, that is every pair of features being classified is independent of each other to start with. Okay, now one of the most simple and effective classification algorithms is nothing but the Naive Bayes classification algorithm. Okay, this is commonly used for classification problems, highly as I told you in text classification. Okay, now this model actually predicts the probability of an instance belonging to one class within given set of features. That assumes that one feature of the model is independent of existence of another feature. Okay, in other words, to simply put, I can say is each feature contributes to the prediction with no relation between each other. Okay, so when I talk about real world, this particular algorithm or this condition satisfies rarely, but it uses Bayes theorem in the algorithm for training and prediction. Okay, now before we actually go into the algorithm in depth, let's talk about Bayes theorem. Okay, now Bayes theorem actually provides the way to calculate the probability of an instance occurring based on the prior knowledge or evidence. Okay, so we have these terms where we give P of C given X is equal to P of X given C into P of C by P of X, where this is called as posterior probability, that is the expecting or the probability of class C given the features X, and then depending on this we will also calculate the likelihood, the probability of feature X given the class C, and then this is called prior probability, this is called as marginal probability. Okay, so marginal probability is nothing but the total class of probability of the features X. Okay, the total probability of the feature X. Prior probability is nothing but the initial probability of class C, that is before seeing the features. Okay, so this is Bayes theorem which all of us know. Okay, so Naive Bayes classifier, as you can see, I have multiple inputs given here. So based on this I will go for probability of calculation of A given B, which is calculated as B given A into P of A by P of B. Based on this I have my classification done. Okay, now let's see how Naive Bayes classifier actually works. Okay, so the classifier uses the probabilities from Bayes theorem to predict the most likely class for a given instance. So we have some step-by-step procedure to it. So let's see what is that. First we calculate the prior probability. First we calculate, say, as you can see, first we calculate prior probability P of C, we calculate P of X, X given C, and then put this into the formulae. Okay, so as you can see, first we calculate the prior probability P of C for each class C from the given training data, and then we'll compute the likelihood, that is likelihood is nothing but P of X given C. First calculate prior probability, then calculate the likelihood, that is P of X given C, and then After that, we will go for prediction phase. Okay. Now, depending upon the instance given, for example, if you have x where x is equal to 1 to n, okay, we'll calculate the posterior probability for each class. Okay. What is posterior probability? Posterior probability is nothing but c given x. Okay. So, this is given as arg max of p of c given x. Okay. So, we have different types of naive Bayes classifiers again. The calculation or the procedure step varies for each of them. So before we actually see how to calculate the posterior probability and all that using Bayes theorem, we will see different types of naive Bayes classifier. First one is Gaussian naive Bayes classifier, wherein in this particular case it assumes the data that follows a Gaussian or normal distribution. We use Gaussian naive Bayes for continuous data basically. Okay, so when you have document for classification where feature frequencies are drawn into multinomial distribution, we go for multinomial naive Bayes. And then when you have binary data, okay, when the features are binary or when you have the entire data set with binary values, we go for Bernoulli naive Bayes. Okay, just remember, for continuous data we will use Gaussian naive Bayes. For classification, multinomial multi-label classification, we will be using multinomial naive Bayes. And then if you have binary data along with feature input and output, we go for Bernoulli naive Bayes. Okay. Now let us understand about naive Bayes classifier algorithm in detail by looking into one example. Let's consider spam email classification. Okay. Now there are two steps in carrying on with algorithm. First is called training and the second one is called prediction. Okay. Now let's take an example. As I told you, naive Bayes classifier is mostly used for text classification. Okay. Text classification in the sense email. Write an email and check if the email belongs to which class, spam or not spam. Product review. Write the product review, the text in the form of text and classify whether the review is positive, negative or neutral. Okay. So first let's take an example of email spam classification. So in the training, first of all, we have to classify the emails into spam and not spam. So we have to first calculate probability of spam, probability of not spam. After that, we have to calculate the likelihood, probability of number of words in that spam which declares a spam and probability of words that declare not spam for all the words. Okay, because usually when we do sentence classification, we do it based on some words. Okay, so we have to describe probability of how many words which will describe the email to be a spam. We have to describe probability of how many words which describes it is not a spam. Okay, after that, when we go for prediction, whenever a new email comes, we have to calculate probability of spam with respect to the email, probability of not spam with respect to the email content that we have received. So in this way, we can classify whether the email is a spam email or a not spam email by calculating the higher posterior probability. Okay. Now, the naive Bayes, as I told you, consists of two words, naive and Bayes. Naive because it assumes the independency between the features, Bayes because it is based on Bayes algorithm. Okay, if you want to use the algorithm, these are the steps. First, we must convert the presented data into frequency table, and then after you do that, you have to create a probability table by finding the probabilities of all the features. As I told you, here I have two features, spam, not spam. So probability of spam is being calculated, probability of not spam is being calculated, and then we will use the Bayes theorem in order to calculate the posterior probability. Okay. So this is what we are going to do. So let us consider a data set. Okay. So in the last session when we were talking about decision tree, we have considered one data set which is playing tennis or not. So depending upon the weather condition will decide whether a person can play tennis or not. Okay. Now let's solve the same problem using naive Bayes theorem. Okay. So if the weather is sunny, the player should play or not. Okay. So we have 14 instances given here starting from 0 to 13. Okay, so for which outlook has different parameters, rainy, sunny, overcast, rainy, sunny, overcast. I am only taking one attribute which is outlook. Okay, now for this outlook I have 14 instances and the probability of them whether we can play tennis or not. Okay, let's see how do we solve this particular data set for using naive Bayes algorithm. Okay, so as I told you, the first step is to convert your data into frequency tables. When I talk about frequency table is nothing but how many times is rainy there, how many times it is yes, how many times it is no. As you can see, out of these 14 instances, I have 1, 2, 3, 4 Rainis. Okay, so as you can see, Rainy is given 4 times, out of which Rainy S, Rainy S, Rainy No, Rainy No. So out of 4 Rainis, 2 are yes and 2 are no. So the same thing I am putting. Okay, Rainy, no is 2 times, yes is 2 times, total it is 4. Similarly, I'll go with Overcast. Okay, so Overcast 1, 2, 3, 4, 5, out of which 1 yes, second S, third S, fourth S, 5 S. So all 5 are S. Okay, so Overcast, no is 0, yes is 5. Similarly, I'll go with Sunny. Sunny 1 S, 1 no, 2 yes, 2 no, 3 yes. Okay, so Sunny 3 yes, 2 no. So altogether I have 5 Overcast, 4 Rainy, Sunny 5, total 10. The probability of no is 4 out of 14. Probability of S is 10 out of 14. So in the next we will calculate the likelihood or probability of each class. So as I told you, probability of no is 4 out of 14, yes is 10 out of 14. So 4 out of 14, which is 29%, 10 out of 14, which is 0.79%. Probability of each category, 5 by 14, which is 35, 4 by 14, which is 29, 5 by 14, which is 35. This is called as likelihood or probability table. Okay, so what did I do first? I've converted into frequency table, how many instances of yes and no, and second I've calculated the likelihood or probability table. Now let's apply the algorithm to our case. Okay, now you have to decide yes based on Sunny, probability of yes based on Sunny, that is equal to probability of Sunny given as into P of S by P of Sunny. This is our Bayes theorem. So we have to calculate for everything, you have to calculate, then apply the values. Okay, so in this way you will be getting a approximate value. Okay, so here I say probability of yes given Sunny is greater than probability of no given Sunny. So on a sunny day the player can play a game because yes of Sunny is greater than no of Sunny. So in this way we apply Bayes theorem for each instances in the given data table and check the probability, and if the probability of S is more than no, then we say that the player can play tennis. Okay, so this is how we apply the algorithm and calculate. Okay, now when we talk about advantages of the algorithm, this algorithm is very simple and fast because there is nothing other than calculating the Bayes theorem, probability calculation, there is nothing more than that. And second thing is it is scalable because it handles large data sets as well. Next is performs well with small data, handles high dimensional data as well. So these are some advantages of Naïve Bayes algorithm. When I talk about disadvantages, independence assumption. As I said, Naïve assumption is actually taken into consideration here, which is one disadvantage. Not in all cases, but maybe in few data sets you may find this a disadvantage. Okay, may not perform well if the data's distribution is continuous. Okay, Gaussian distribution, in the case of Gaussian Naïve Bayes, it may not work so well. Okay, so text classification, mostly we use Naïve Bayes algorithm in text classification. Other than that, for other classification algorithms like medical diagnosis, recommendation systems, face recognition, there are so many applications in which you can still use Naïve Bayes classification algorithm. Okay, so this is all about Naïve Bayes classification algorithm, which is totally dependent upon Bayes theorem. Thank you so much.